The sliding filament theory. For step 1 of the sliding filament theory, we first have actin as shown below. They look like attached beads. Similarly, we have myosin, which cross-bridge attaches to actin because it would like to interact with it. In order for these two to interact, ATP, which acts as the energy source and access to actin, is needed. Here is where tropomyosin comes into play. It comes in between myosin, preventing it from attaching to the actin because tropomyosin acts as a block. In order for myosin to get past this block, myosin will need the help from calcium. From this point on, the calcium will attach itself to the tropomin. This will allow tropomyosin, which was the block, to move out of the way, resulting in the myosin to get access to the actin. And from this point, the myosin performs a power stroke. When the myosin head gets detached, the ATP turns back into ADP and phosphate. The energy source, which was the ATP, comes along and attaches itself to the head of myosin. When this happens, it releases the myosin head from the actin filament. In other words, the ATP releases from the myosin head and cross-bridge detaches. During the power stroke phase, the myosin and actin are no longer separated. The ADP and the phosphate are released from the myosin head, which are triggering it to spring forward. When the ATP converts back to ADP and phosphate, the myosin head returns back to its starting position. At this point, the myosin head pivots and bends as it pulls on the actin filament, sliding it towards the M line. This allows the entire process to repeat itself. This process allows muscles to contract and move, concluding the sliding filament theory.